All right, good morning, Calculus 2. So we are going to talk a little bit about differential equations today, and this is actually called separable differential equations. Okay, and the reason they're called separable is because you can put all the variables on one side and put all the other variables on the other side and integrate side by side and call it a day. Okay, so what you're trying to do here is, like for this first one, okay, what I'm trying to do here is I'm going to say, well, we have dy dx, and we could say, well, we have square root of xy, so this is going to be equal to 3 square root of x times square root of y. All right, we're allowed to do that. That's how square roots work. Okay, we'll turn it into a calculus problem by saying something clever like dy dx is equal to 3x to the 1/2 y to the 1/2. And now all we're going to do is we're just going to push everything on one side, all the y's on one side, all the x's on the other side. So we're going to have dy y to the 1/2 down here is equal to 3x to the 1/2 times dx. Okay, now we got one more step to go before we can integrate, right? And I should have done this over here, but this is y to the negative 1/2 dy is equal to 3x to the 1/2 dx. Okay. Notice that we just have a thing with y's. We just have y's in this part of the equation. We just have x's in this part of the equation. So we can go ahead and integrate both sides. So this is y to the negative 1/2 dy. This is 3 integral x to the 1/2 dx. Okay. And then we just go ahead and integrate. So that's going to be add 1. So that's going to be y to the positive 1/2 times, well, divided by 1/2, which is going to be 2. Okay, and this is equal to 3x, and this is going to go up by 1, right? So 1/2 plus 2/2, that's going to be 3/2 times 2/3, because that's what the integration power rule means, plus c. So we're going to be sitting here with a 2y to the 1/2 is equal to, well, the 3's cancel, so we're going to have 2x to the 3/2 plus c. Now we can go ahead and divide by 2. Okay, so the 2's are going to cancel. So we have y to the 1/2. Okay, and then on the other side, we're just going to have x to the 3/2. I'm going to divide c by 2, but it's a constant divided by 2. It's still a constant. So we're just going to call it c. All right. This happens a lot in differential equations where they pretty much take a lot of liberties with c just stays c. If you multiply or divide or raise to an exponent or take a logarithm, whatever, it's still just c. So we tend to do that with these rather than tracking like c over 2 here. Okay. The last thing we have to do is say y is equal to x to the 3/2 plus c squared. Now this one, I can't just divide, can't just put this in, because if I'm going to square, right, we have to do a FOIL thing. So that's not going to work, where I just can't distribute the 2 in here. See our answer, and we're good. Okay. So next one, these are very similar problems. Okay. So my apologies for that. I actually gave this one on a quiz one time. So I'll do this one. So this is just dy dx is equal to 64 xy to the 1/3 power. We'll go ahead and break that apart. So this is dy dx is equal to 4, right? The cube root of 64 is 4. This is going to be x to the 1/3, y to the 1/3. So we'll just go ahead and separate them now, because we can divide both sides, or actually multiply by y to the negative 1/3. Okay, that'll save us a step. You can divide and then make it a negative exponent. That's fine. If you need another step than I did, then nobody's going to judge. Okay, so we have y to the negative 1/3. This would happen to both sides. Here, okay, now y to the negative 1/3 dy, and this is equal to 4x to the positive 1/3 dx. And again, notice we have all the y's on one side, all the x's on the other side. We're ready to integrate. So we're going to have, we have to add 1. Okay, so that's going to be y to the 2/3. We have a 3/2 here, right? Because we divide by 2/3. And that is going to be equal to 4x to add 1. That's going to be 4/3 times divide by this. That's going to be 3/4 plus c. And then we'll go ahead and do that one as well. So these 4s, these are going to cancel. So we have 3/2 y to the 2/3 is equal to, these cancel, so we have 3x to the 4/3 plus c. We could multiply everybody by 2/3. Multiply everybody by 2/3. 2/3 times this thing here, that's just going to be 2. So we're going to have 2x to the 4/3. Sorry about that. Again, we're going to have 2/3 times c. Well, again, that's just c. All right. And then what we're going to do is take everything to the 3/2 power. Okay. So we're going to have y is equal to 2x to the 4/3 plus c, all raised to the, right, all raised to the 3/2 power. Okay. And again, we don't want to, don't distribute the exponent in here. You got to do like a cubic thing, and then you got to take the square root, and it's going to be really ugly. So just leave it that way, and we're good. We have a function in terms of y here. All right. So let's see here. So that's how we would do it. Okay. The next one is a little bit different. Okay. This is y dy dx is equal to x squared plus 1. Okay. So this is y dy dx is equal to, I think this was what? This was x y squared plus 1. X y squared plus 1. So again, we're just going to divide by the y's and see what happens. Divide, just multiply both sides by dx. So we're going to get y over y squared plus 1 dy is equal to x dx. Okay, so that's how that happened. This went down on the bottom, this came up on the top. Okay, this is when we have to use a u substitution. So separable differential equations, it sounds like it could be a hard thing, and some of them are, but for a lot of classes, this is just an excuse to give you other integration problems, preferably of ones you've practiced before. Okay, so could there be an integration by parts in this? There could be. I'm not promising that there will be. Okay, we'll talk to you guys about that in a moment too. All right, so this is going to say, well, this is a u substitution, right? So we're going to say let u equal y squared plus 1. Okay, du would be 2y. So if I put a 2 in here and a 1/2, okay, this is now my du, and this is my u. So we're going to have 1 over, well, 1/2, 1 over u, right, because that's what this one was, times du equals x dx. And now I believe we are ready to integrate both sides. So this is going to be 1/2. Okay, you can put the 2 on the other side, that's fine. Okay, natural log of u, that's how we integrate 1 over u du. That equals x squared plus c. Okay, and now we'll go back to y space. So this is 1 over u, ln, what the heck is u? U is y squared plus 1. This is always going to be positive, so we don't need the absolute values anymore because this is always a positive number. Okay, this is equal to x squared plus c. Multiply both sides by 2. Okay, so we're going to have 2x squared plus technically 2c, but we're just going to call it c. Okay, because it's twice a constant is a constant. Okay, so we have ln y squared plus 1 is equal to 2x squared plus c. And now we're going to unlogify. That's not a real word. Okay, I made that up. Okay, but we're going to take the anti-log of both sides. That's the right word. So we have y squared plus 1 is equal to e to the 2x squared plus c, but watch this. We have y squared plus 1 is equal to e to the 2x squared times, right, e to the c. That's what that plus means. It's a times button on the bottom. It's a plus in the exponent. It's a times on the baseline. And e to a constant, well, that's a constant. So we're just going to replace that with c. So we have y squared plus 1 is equal to c e to the 2x squared, okay? And then we can subtract 1 from both sides, okay? Now this one we can't just say, well, it's a constant, because this constant is times e to the 2x squared, okay? So it's different, right? So then y would be plus or minus the square root of c e to the 2x squared minus 1. And that would be our solution for this thing, right? So generally, they want you to get this in terms of just one y equals some stuff, okay, because that's easier to graph. Sometimes you can't really do that, okay, like we don't really deal with those functions. Like if you ended up with sines or cosines or tangents or stuff, you might not be able to do this. And it might just be really inconvenient to do this, so they generally just don't. So it's like, well, how do I know? Try to put it in terms of y. If you end up with more than one y term, then chances are like that's not going to work, okay? So for some reason, if you ended up with like y over y plus 1 equals like some function of x in it, I would just leave it, okay? You can kind of play around and do something with this, but at that point, they're starting to ask a lot of questions, like a lot of questions that are going to be involving a lot of algebra. So I wouldn't necessarily go through and do all of this, but if you can put it in terms of y equals, you should do it, okay? Let's see, back up here. That was this one, okay. So let me make one up that has an integration by parts in it. Okay, so if we do a we'll do dy dx equals, and it's really easy to put one in. I could just say x e to the negative x divided by y. At that point, all we do is say, well, this is y dy. Okay. Actually, I could probably put it on top too. That would be okay. And then we'd have x e to the negative x dx. And when you see a polynomial times an exponent or a polynomial times a logarithm, that's generally going to mean you have integration by parts. Now, if there's a u substitution here that will take care of this x, like for example, this is not the problem we're working on, but if I ended up with an x e to the x squared, this is a u substitution, because as soon as we say let u equals x squared, du equals 2x, and now this polynomial here, this is part of your integration factor for this guy. Okay, so we don't need to worry about this because the u substitution took care of it. But that's not happening here. Okay, you can say, well, let u equal negative x. Like, great, du is negative dx. And that's not going to help. So we have to do integration by parts here. Okay, and generally for this class, that's your major concern. Is like, well, is this a u substitution or is it integration by parts? Try the u substitution first. Maybe you get lucky, you get something like this, and that works. But generally, you're looking for polynomial times exponential or polynomial times logarithm. Okay, I know if you look up integration by parts, you'll see something like this. Okay, LIATE or something. This is what to pick for your DV for integration by parts. It's like logarithm, inverse function, algebraic, trigonometric, exponential. Okay. Inverse, algebraic, trig, and exponential. You only dealt with this function, and this function. This is a lot to remember for stuff that you're never going to use. Okay. So understand that you know, you could make this more complicated and more complete, but you really don't want to. You want to just like, these are the two cases that you're going to be dealing with, is logarithmic and exponential. Okay, occasionally there'll be an algebraic one, but that's what you want to pick for your dv here. So we'll say let u equals x, dv equals e to the negative x. We're going back to here, obviously. Du is equal to dx. V, we have to integrate this. This is negative e to the negative x. So we have negative x e to the negative x minus the integral of negative e to the negative x dv, or dx rather. Yeah. We have negative negative, so we're going to cross those out and just put a positive here. And all we have now is we have negative x e to the negative x, integrating this guy here. Okay, this is going to be minus e to the minus x plus c is equal to, right, y squared, integrating this side here, y squared over 2. Okay, and then we're ready to go. So I'm just going to multiply by 2 and then take the square root. Okay, so we have c, I'm just going to write it first because it doesn't have a minus sign, minus 2x e to the negative x minus 2 e to the negative x. So why was it just multiplied by 2? Well, I did, but I noticed that 2 times a constant was just a constant, so turn it back into a constant. This is equal to y squared. So y is equal to plus minus square root c minus 2x e to the negative x minus 2 e to the negative x. I'm not going to promise you that's always going to be the case, because, you know, I already know you're learning integration or differential equations, separable in this case. But be on the watch for it. It's not, I'm not going to promise you that's going to happen, but I'm just saying, like, be on the watch for it. Okay, because it might be something you do. I know it's never, they don't put those in homeworks. They should, but they don't. Okay, so that's a integration. There's a separable differential equation that also features an integration by parts. Okay, so that's integration by, that's separable differential equations. I'll add to this and give you guys a little bit more room. Okay, so thank you, and I'll see you in the next video.